Hi everyone, welcome to our first online video lecture for the class MBA 693 Business Analytics. I've already introduced myself in the video where we covered the syllabus and some of the expectations for the class, but in case you're watching this video first, my name is Nilofer Verskhani. I'll just quickly introduce myself and give a little bit of information about my background. I'm relatively new to LaSalle. I joined about a year ago. Before that, I was in consulting. I was in the procurements analytics solution division at A.T. Kearney, which is a consulting firm. So I did 2 years of consulting, and before that I was completing my PhD from Rutgers in management science operations research. My bachelor's was in finance, so my research interests are in financial analytics and in the operations area to improve efficiency, productivity, and performance. So here at LaSalle, I've been teaching for almost a little over a year. I teach analytics classes to undergraduates and graduate students. Some of the other courses that I teach are prescriptive analytics, data mining, data warehousing, both to undergraduate and graduate levels. So welcome to my class. If you have any questions or concerns, please email me. My email is provided in the syllabus and on the Canvas course for this website. So let's talk about business analytics. Since this is an introduction class and we're not going to be covering any of the technical stuff, we'll only talk about how we define business analytics specifically for the purpose of this class, and what is the scope of business analytics, and what are the different ways that people are creatively using analytics in the area of business, including specific areas such as finance, HR, marketing, supply chain, etc. So business analytics is sort of a buzzword these days. You hear it a lot. It's used almost everywhere. That's mainly because decisions now are becoming more and more data driven. The reason for that obviously is we now have so much more data. There's so much access to data that everybody's finding new and creative ways to use that data in order to run businesses more smoothly, more efficiently, and to increase revenue, as well as on the cost side in how to decrease cost with the help of all the information that has been given to us. Although business analytics is an extremely relevant topic right now, there is still some discrepancy as to how we define business analytics, because it can mean anything. It's used everywhere and anywhere. So sometimes it gets confusing when we try to draw lines between different disciplines within business analytics itself. For example, how is machine learning different from business analytics, or how is data science different from business analytics? So there's no specific definition as to what we call business analytics. It's just an extremely wide umbrella term that is used all across the industry. But just to get a visual perspective of business analytics, think about it of business analytics as sort of the merging of statistics with information systems and modeling and optimization. So when you bring these three separate disciplines together, we end up having a new discipline which sort of borrows from all of these 3 different disciplines and comes up with ways on how we can use technology and data to improve our decision making process and skills, and eventually be able to make decisions which are more informed and which have fewer risks and uncertainties associated with them. Now, when we talk about this sudden growth in the use of analytical models, that mostly comes from 3 developments in our age. The first one specifically is technological advances. Obviously, with technology growing as much as it is right now, data collection has become so easy, and data is essentially everywhere. From our online presence in terms of social networks to e-commerce, online shopping, there's so much more information that's available, recorded, and stored that it would be a waste to not use it for better decision making. The second development that has led to this huge growth in analytical models is that there has been a lot of research that has been conducted in the recent years on how these methods, which were years and years old, and how can they be improved. So in terms of computational efficiencies, in terms of faster algorithms, and in terms of software that is more end user friendly rather than being catered to a specific sector of people that are they're basically fluent in coding and programming. That's not the case anymore, because now the end user is the person who's creating the models, and all these softwares with great UI UX make it really simple for the end user to not know coding but still be able to apply all the analytical methods and techniques. The third development is in terms of computing hardware. So you have so much computing power and storage capacity now that it's easier to record and store that data that was available earlier as well, but we couldn't store it and record it and use it efficiently. But now all of that has changed thanks to a number of developments in technology. So business analytics can be viewed sort of as a combination or an integration of business intelligence information systems, statistics, and modeling and optimization. There's a nice little chart towards the end of the slideshow, which sort of talks about how the advancement happened. But for now, think of it like the unique interaction of statistical modeling, optimization methods, and all of the data that is available and stored through information systems. So it has become this unique interdisciplinary approach to track useful information out of this huge pool of data that is out there, and identifying the patterns that can basically help us predict and forecast and make better informed decision going forward. And this is a hot topic these days, because I was just reading in the McKinsey report for the future of jobs in America for this year, and the second largest growing sector is the STEM sector, which is science, technology, engineering, and math, and that can be attributed to this trend in analytics jobs that is basically on fast track. So if you have some sort of knowledge or skill set in this area, you're going to be a hot commodity in the jobs market. Everybody's going to want your skills because that's highly needed in the market right now. And the job titles for a person who is savvy with business analytics can range from anywhere from a business analyst all the way to solutions architect, data engineer, data scientist. So there are different ways people use these skill sets across different businesses. Let's talk about a little bit about decision making and how this trend in business analytics has helped us overall. So whenever we are running a business or working as an employee for a larger corporation, everybody has to make decisions, right? But the way decisions are categorized is we can think of decisions as either strategic decisions, tactical decisions, or operational decisions. And in that order, it sort of is a top to bottom approach. Strategic decisions are more high level decisions. So all the C-suite people, the executives, they make these strategic decisions about where the vision of the company or the business is, what do they plan for the future, what are the big picture goals for the company. Then we have tactical decisions, which basically concern how the organization achieves specific goals and objectives and the strategy to do that. So for example, if a company has the objective to increase its revenue by 20% in the next 5 years, that would be a tactical decision. Operational decisions are more on a day-to-day basis. These are low-level decisions. I'm calling them low-level because this is specific to each employee and how they run their day-to-day operations. But I'm not saying that they're not important. They're definitely important. It's just they're more targeted and more specific than tactical or strategic decisions. Now, business analytics basically gives us information that is valuable to making all three of these decisions, but the category of decision making which it has affected most is the strategic decision making, because now companies have information and enough predictable power to make these forecasts that are more accurate, make predictions that are more accurate, and help design their strategies in a way that those predictions are met. So all in all, business analytics and the growth in this area has basically helped strategic decision making skills the most. Now, when we think about decision making, we do it all the time in our day-to-day daily lives. But when it comes to business analytics and decision making, it's a more scientific approach to decision making. So you're not just making decision based on a rule of thumb, or because you've been doing this for years and years, or because you have a gut feeling or an intuition to do that. You're making this decision in a systematic and procedural manner. That is why the way we study decision making with the help of business analytics is more scientific in a way, because you follow these steps every time, and even though you might not get the outcome that you expected, the process itself is so systematic and so rational that it justifies whatever decision you made based on the information that you had at that particular point in time. So this systematic process, you can think of it like an algorithm which can be repeated in a loop. The first step is identifying and defining the problem. This, according to me, is the most important step, where you identify and clearly pinpoint what the problem is. The second step is to determine the criteria that will be used to evaluate the alternative solutions. Obviously, if you're making a decision, you have a bunch of options available from which you need to decide. So the criteria that you use in order to judge and evaluate each alternative solution has to be clearly defined. Then you have obviously that set of options that you need to decide between. These are your alternative solutions. Fourth is evaluating each alternative based on the criteria that we determined in step number 2. And then finally, selecting an alternative which we think makes the most sense based on the criteria, again, that has been defined in step 2. So for example, if we take an example in the production sector of a business, let's say that a business has a profitable product that is selling currently right now, but they want to introduce a new product which is slightly related to their old product, and they're deciding whether, number one, they should launch this new product or not. Number two, should they launch the product by setting up a large manufacturing plant, either by launching a small manufacturing plant, or by outsourcing it to a contract manufacturer who can create the product for them and they can just do the selling, or not introduce the product at all. So this is the step where you have to identify the problem, and the problem is what should the business do if it has a new product idea, and what is the route that the business should take. The second step would be to determine the criteria. So this criteria could either be, for this particular example, could be on the revenue side, based on the demand in the market, or it could be on the cost side, which means it's based on how much it's going to cost you to set up the operations for this new product. And thirdly, we have the set of alternatives. This I already mentioned. The company can either build a large plant, build a small plant, outsource the manufacturing, or not take advantage of this opportunity and just stick to its existing product, which is profitable. The fourth step is evaluating the alternatives based on the criteria. So if you chose the cost criteria to make your decision, then you would determine what the cost of each alternative would be, compare it to the revenue side, depending on what type of demand forecasts you have, and then between the two, which alternative makes most sense or has the highest payoff would be your best option available from all the alternatives that you have listed down. So in essence, it's a very systematic approach. It's easily justifiable, and it's not based on gut, it's not based on emotions or biases. It follows a certain strict criteria that needs to be evaluated every time you make this decision. So this way you basically get rid of unwanted bias and unwanted prejudices in your decision-making abilities, and it's more data-driven, so it's more fact-based. So now let's talk about business analytics defined. The way we define it for the purpose of this class is as a scientific process where we can transform data into insights for making better decisions. Here, what is valuable is the information that the analytics process is giving us, and that information is what we can turn into more profits, increased efficiency, improved productivity through the use of data-driven or fact-based approaches, which is more objective than the alternatives that I just mentioned earlier, based on basically your experience or gut feeling or rules of thumb that you've been following for years and years. The tools that we use in the area of business analytics, they help us create insights from data. So that's why there's a particular segment of business analytics which is called data mining, where we specifically mine within the data to find information that's valuable. It helps improve our ability to forecast and predict more accurately. All of our predictive models, they can be run with large amounts of data, which make the model more accurate and robust, and it's more representative of the population that you're trying to estimate for. It helps us quantify risk. So risk is no longer just a vague word that is thrown around. It has a specific definition, and you can put a numerical quantity on it. It yields better alternatives through analysis and optimization. Now, generally, there are different books and different experts that define analytics differently and the scope of analytics, but for the purpose of this class, the categorization of analytical models that we're going to stick to, it basically categorizes business analytics into 3 separate categories. The first category is called descriptive analytics, the second category is called predictive analytics, and the third category is called prescriptive analytics. Now, each of these categories are a separate discipline on their own, so to speak, because of all the models and techniques available under each category. But just to give you an overview of how these categories are different from each other, think of a step-by-step approach. So descriptive analytics comes in as the first step to data-based, data-driven decision making, because in descriptive analytics, you study your data specifically on its own. So here, you're not applying any model on the data, or you're not making any predictions on the data, but instead, you're trying to understand your data in depth. That's why it's called descriptive, because it helps you describe the data. By describing the data, I mean, what type of data do you have? Do you have data that is more quantitative in nature, so numbers? Or do you have data that is categorical? So categorical data is data that's not numbers, but instead it just classifies your objects into separate categories. So for an example of categorical data is gender, male, female. Another example of categorical data is the marital status of somebody. Is the person single, married, divorced? Another type of categorization could be that it's ordinal. So for example, your grades are ordinal categorical data because you have letter grades, and the way the letter grades are defined, it's ordinal in nature. So an A is better than a B is better than a C, but each letter grade is a category in itself. So here you try to understand what type of data do you have in hand, and then from there, we can take it forward as to what types of model can be applied to each type of data. But for now, we're just trying to understand our data. What is our sample size? How big is the sample? Does the sample have subgroups in it? If yes, how are these subgroups divided? What are the factors that separate one subgroup from another subgroup? Do we have outliers or not? How is our data distributed? Do we have most of our data values around the mean or not? Do we have values that are way off from the mean? And how is the spread across these values? Are the values very different from each other, or are they close to each other? All of these questions are the questions that we try to answer in the descriptive stage of analytics, because we are trying to understand our data better. Once we have understood the data, we can move on to the next stage, which is either making predictive analytics models or creating prescriptive analytics models. So predictive analytics models, just as the name suggests, is making forecasts about the future. You try to predict with your existing data what the future would be. So for example, if I am running an online business, then predicting what my sales would be for the next year would be a part of predictive analytics. Or if, let's say, I'm working for Netflix, then a part of the predictive analytics team at Netflix would be to determine or to predict what kind of movies you specifically as a customer would like to see, and which movies or categories of movies would be of interest to you based on what you've previously watched. Then we have prescriptive analytics. Prescriptive analytics is sort of more of a technique that is designed to help the decision maker in a way to optimize and find the best alternative, or to reach specific goals such as minimizing overall cost or maximizing overall profits. So prescriptive analytics is used in many areas of business, to determine the best pricing strategies, to determine the best advertising strategies that maximize revenue, to determine the optimal amount of cash to store in ATMs, for example, or to find the best mix of investments in a retirement portfolio account. So all of these are examples of how prescriptive analytics could be used. Mostly under predictive analytics, we use a lot of statistical techniques that help us create those models. In prescriptive analytics, we use a lot of optimization techniques to help us build those models. If you go through the syllabus, you'll come across that I've created this key next to the weekly schedule for each of the topics, which tells you which topic belongs to which category in analytics. Now, because this is an MBA level class and it's not too technical, we're going to stick to a lot of descriptive analytics so that you know your data as an MBA graduate, and be able to determine what type of model to apply. So that would come under predictive and prescriptive analytics. Now that we've covered the three different categories that come under the scope of business analytics, let's talk about another buzzword, which is big data. Big data is a term that is thrown around generously around us everywhere by everybody, but there's a specific definition to big data, and that usually comes from the 4 V's of big data. This includes volume, velocity, variety, and veracity. These 4 V's are how we specifically define big data. So if you want to know more about what each of these 4 V's mean, I've switched on to slide number 23 of the slideshow. Here it tells you that a data set can be categorized or defined as big data if it follows all 4 of the requirements of these V's. The first V is volume, which refers to the size of your data set. When we talk about big data, we're not talking about data which can be stored in Excel sheets anymore. It's just so big that you need to use a more advanced tool to try to analyze the data set. If you've ever worked with Excel extensively, you'll know that after 100,000 rows, Excel basically crashes on you. So it's not equipped to deal with big data. The sheer volume just makes it impossible to store it in any simple software. So you need a better computing model to help you store that and analyze that data set. The second V refers to velocity, which is the speed in which the data is updating. With on our online lives being so fast, the amount of data collection and the speed of data collection, not just the amount, has increased tremendously. So we have data that is updating almost with every passing second. The variety V of big data refers to the way the data comes to us. So the data can come to us in different forms. It could be textual data, it could be quantitative, so in numbers. It could be structured, which means that we can store it in a regular table format, or it could be unstructured. So for example, all of your tweets from Twitter is unstructured data. Your photo data is unstructured data. Audio content is unstructured data. Video content is unstructured data, which means by unstructured, we mean that it cannot be saved and stored in a traditional table format of rows and columns. So big data can consist of not just one form of data, but multiple forms existing together. So for example, if you have a movie content, that would come under unstructured data because it has audio, it has video, and it might have subtitles, so it has textual data as well. So big data generally has this characteristic that the data comes in a variety of formats. The fourth V and the last one is veracity, which means the amount of uncertainty that is related to the data. The incompleteness or the inconsistency of the data itself can be really high. This is very true about social media data. So if you're ever doing a social media analysis, you'll come to know that the data that you get from social media is extremely uncertain, it's inconsistent, it's incomplete. People use slang all the time. So that just adds to the difficulty and the challenges of dealing with that kind of data. Now, in addition to the 4 V's that I just mentioned, people have tried to expand this definition, and you would probably see the 5 V's now or the 6 V's as well. But these 4 main V's are what help us define and categorize big data. There are new technologies in the market that have helped us deal with big data. The most prominent of them is Hadoop. It's probably you're going to hear this name a lot if you go into analytics. Hadoop is basically an open source programming environment that supports big data, and it helps us with the storage and processing of the data. So think of it like a tool that can help you manage big data properly. MapReduce is another tool. It's a programming model used inside of Hadoop that helps you map the data and then reduce the dimensions of the data in a way that it makes it workable. Data security is another feature that comes with big data. It's more of a challenge because the higher amount of data you have, there's possibly a lot of information in that data. So if somebody gets their hands over that data, it might be they could use it in ways that are not authorized, or they're destructive for the business that we're talking about. Okay, let's talk about business analytics in practice. Analytics has a number of applications in every area of business that you can imagine. I'm going to go over some of the examples of how it's used in each of these areas that are listed on the slide here. But even outside of this list here, there are a number of areas in business that probably use analytics in an efficient and in a manner that helps with the operational as well as the strategic side of the business. An example of analytics in finance is in portfolio management. Portfolio managers can use analytics to help decide what is the best way to maximize their return on investment by selecting the stocks that have the least amount of risk and the highest amount of returns. And it's not just about one particular stock, it's about a combination of stock and how the correlation between the stocks can help you create a model that maximizes your return and at the same time keeps your risk at check. In human resources, analytics has played a huge part in helping you assign people with skills to jobs and projects. So there's a lot of staffing models, there's a lot of assignment models that help human resource professionals in making placements that are more specific for the person as well as the role. Marketing analytics is huge in terms of where to spend your dollar. Let's say, for example, in advertising, where the return would be the highest. In healthcare analytics, people use analytics in a number of ways, from insurance to even deciding how many beds to put up in a hospital so that the return on putting on those beds, both financial and moral, can be maximized. When we talk about supply chain analytics, it can mean anything from logistics and transportation all the way to procurement and where and how you get your product to either your warehouse or to the direct to the customer. Analytics for governments and nonprofit, you might have seen this already, but a lot of campaigns across for political candidates use analytics to help understand their audience and their voting preferences. Sports analytics is huge as well, where we try to analyze the performance of either the players or the teams. It could be done through data from wearable technology, or it could be done from data that is recorded throughout the games and the matches. Web analytics refers to how we can make our online experience more smooth and effective and efficient. You would notice this if you compare Amazon to any other online e-commerce platform. Amazon has made it so easy to go through the whole process of putting something in your cart, selecting it, getting it delivered to your doorstep, that all the other players in the industry are trying to catch up. So these are just some of the examples the way business analytics is around us these days, and how we could possibly familiarize ourselves with these applications and be able to take advantage of them. So now that we know how we define the scope of business analytics, I just wanted to go over this neat chart that you see on slide number 26 of the PowerPoint slideshow for chapter 1. This just shows you how each task in business analytics is classified in terms of its competitive advantage, its degree of complexity, and across the 3 different categories that we just discussed earlier in the lecture. Now, standard reporting is just your everyday operational procedure where you report how many items were sold. This is basically transactional level information. Then you have data query and data visualization. This is pulling out information from your data warehouses or wherever your data is stored into a format that is understandable to the higher level management and helps you identify patterns and trends. Then you move on further to descriptive statistics, which help you understand your data better in terms of how it's distributed, how spread out it is, and what are the different ways that you can look at the data. So you slice and dice the data to look at different views. Then we move on to more complicated models, which obviously, if they're run right, they can be of a lot of competitive advantage. This includes prediction, forecasting, and data mining. There is no specific definition as to what is forecasting and how it's different from predictive modeling, but think of it more of different lenses of looking at the same thing. So under forecasting, you could be looking at time series analysis, which help you identify future opportunities or help you forecast future values using historical data. A lot of predictive models do that too, but here the predictive modeling is not limited just to numbers. It's also predicting categories and classes. So for example, a bank could be running a predictive model to identify which customers are going to be the ones that are going to commit frauds or would default on their loan payments. That's another way of using predictive modeling. And towards the higher end of the spectrum, we have decision analysis, optimization, and simulation. All three of these topics fall under prescriptive analytics. They help you get the solutions, how to maximize, how to minimize, how to select a particular alternative, how to set the criteria for evaluating your alternatives, and how you could basically create a simulated version of reality that can help you deal with the challenges or the uncertainties that come with that particular scenario of data. So all in all, business analytics is this wide umbrella term that sort of covers all of these specific topics, but for the purpose of this class, we're going to take a bird's eye view and try to cover an overview of a majority of these topics. So we're going to focus on descriptive statistics first, move on to predictive modeling, and then eventually to optimization. I would recommend that you read chapter 1 from the textbook, which gives all the details that I might have missed during this video lecture. In addition to that, you have a self-check quiz, which is due at the end of the week, and that quiz is basically to help you and me understand how much of the information actually was absorbed during the model. Then you have assignment 1, which is due also within a week. And I would also encourage you to please participate in our first online discussion, which is an introduction to the class. Since this is an online class, this is the only way we can get to know each other, all of us who are taking the class. So it just helps us build that connection and rapport so that we can mimic a face-to-face class and reap the advantages of that communication. So please read chapter 1 from the textbook. I have also added a supplementary practice case. That's not required. It's just if you have time, it might be helpful in trying to understand business analytics as a discipline. Thank you. I'll see you guys. Not see, but I'll talk to you guys next week.